All right, hello everyone. So I wanted to do a little bit of a demonstration today where I went through the process of making a solution so you could see why we did some of the math to calculate the molar mass and find the molarity of solutions. So I want to do a quick demo. I have a setup here that you'll see in a sec to help me out. We're going to do some live chemistry, and hopefully you'll learn something too. So we've learned a lot about molarity in solutions. We learned a lot of definition words about solutes and solvents and solubility. But how do we put it to use? So we now know everything that we need to make solutions. And this is the same thing that even very advanced chemists are doing if they're working in a lab. Whenever they got to mix up a solution with something, you know, they're always going through the steps that we're about to go through today. So let's imagine. Let's say you wanted to make a solution that was equal parts salt and sugar. Now, we use that kind of language in everyday life. Oh, equal parts of, you know, whatever, this and that. When mixing together liquids, or sometimes as parts of recipes, equal parts, you know, oil and hot sauce or something. I don't know, people who make recipes. But what do we really mean when we say equal parts? Do we mean equal volumes or equal mass? So we could definitely use equal mass of two things. I could weigh out the mass of one thing, and then I could weigh out the mass of another thing, and then I could add them together, and that would be one way of measuring equal parts. But we know that, you know, not everything has the same density. So if we wanted to use the same volume of two things, for example, we were mixing two different liquids together, say, you know, two different kinds of juices or something. If I wanted to do two equal volumes, well, there's also a problem because sometimes one liquid is more concentrated than the other. So if I was mixing one juice together with another juice, but one juice was stronger tasting juice than the other, then I'm not going to get the same amount of, you know, juiciness from both things. In our case, we're trying to make a solution of salt and sugar. This is actually sometimes used to help people who are rehydrate people who are super dehydrated, either because they're sick or because their digestive system isn't working. So we could do equal parts by mass, but we also have learned a decent amount about molar mass, and what if what we really wanted was an equal part of actual molecules? I want an equal number of sugar molecules and an equal number of salt molecules. And so for every sugar molecule that's in that water floating around, I also want another salt molecule that's floating around in the solution. That's going to require us to do a little bit of chemistry to figure out. I can't just go to the kitchen and start measuring out and counting out. Okay, 1, 2, 3, 4. Okay, that's 4 salt molecules. Okay, 1, 2, 3, 4. Okay, that's 4 sugar molecules. Okay, that's 4 of them. And let me count some more. Okay, 5, 6, 7, 8. That's not going to work. You can't count molecules. They're way too tiny. Even with a microscope, even with, you know, only now at the very fringes of physics are we able to manipulate individual molecules. So more often than not, we're going to have to find a better way of counting those molecules. And I can't do that visually. I can't literally count them. Instead, I have to take advantage of the periodic table. So if I go to ptable.com, you know, every single atom has a consistent molar mass, meaning that if I counted up a mole of things, it's always going to weigh the same, with very little exception. So if I took a mole of sodium atoms, it's always going to weigh this number in the bottom right here. So let's see if I can, whatever. So 22.99 grams. So 1 mole of sodium, doesn't matter where I got it or how I got it or whatever, it's going to weigh 22.99 grams for 1 mole. Now, that's different for other things. Let's say I was trying to measure, you know, gold. Well, gold has almost 10 times as much. This was like 20 or 23 or something for sodium. For gold, it's almost 200. So it's almost 10 times as heavy. So if I was trying to measure out just the masses of sodium and gold, and I wanted to get equal parts, Well, I'd be screwed if I just took the same amount of mass, right? Because if I took the same amount of mass of sodium versus the same amount of mass of gold, well, I'd actually have close to 10 times the number of sodium atoms. So it would totally mess up the balance if I really want just one atom of gold for every one atom of sodium. So with that analogy or example out of the way, we're going to do the same thing but with salt and sugar, which is a little bit more complicated because they're molecules as opposed to atoms, but I think we can do it. So let's say that we wanted to get 100 milliliters, or 1/10 of 1 liter, of this solution. So I have here a beaker. Here, I don't know if you can. Well, let's swap to the. Bam. Let's see if this is any better. You can see a beaker here, and it's got a 100 milliliter mark right there. So we're going to use that to measure out 100 milliliters of our total solution. I'm going to put that there next over here in my little work area here. So 100 milliliters, that's about the same as 1/10 of a liter. So if you imagine a 1 liter bottle, we're going to fill it 1/10 full. Now I could do more liters and more volumes, but I would just need more salt and sugar, and so it's a little bit arbitrary. Okay, now next I want to say that I have a 0.1 molar concentration of salt and a 0.1 molar concentration of sugar. Now, oh, I'm not in the right window. Bam, okay. I want a 0.1 molar of salt and a 0.1 molar of sugar. So notice that these numbers are the same, 0.1 for both of these, 0.1. Or 0.1 if you prefer. So if the concentrations are the same, the molarities are the same, that means it's equal strength of both those things. Does that make sense? So this means there'll be the same number of salt molecules and sugar molecules. But in order to measure this, I can't measure molarity directly. There's no like molarity meter that just you stick in something and it tells you the molarity of a solution. There's no magic like that. Instead, I have to make the solution from scratch, and I'm going to do that by utilizing the molar mass. So the first thing I need to be able to find is the molar mass for each of these. So if I wanted to find, okay, I got this a little bit backwards. The first thing I really want to find is how many moles that really is. So I know the molarity and I know how much volume I'm going to end up with. So we're going to use one of these problems that we've been doing a little bit over the past few days. So let's see. I haven't actually checked the chat once. Is anyone here? Oh, Brandon's here. Hey, Brandon. Glad you're watching. Yeah, so this will be maybe a cool introduction as to some of the stuff that we're doing today, or that we did this week. And then if you want, you should probably go back and watch previous videos as linked on the classroom for information. Yeah, I should have been checking the chat. Maybe I can pop that out so that's on my screen somewhere. Pop out. Bam. 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 Okay, good. That way I can read. Someone ask questions. Okay, so here we go. Making solutions, salt number, bam. Okay, so we need the number of moles. So we're going to use this equation. Moles equals molarity times liters. So moles equals, that's the substitute for the molarity, so 0.1. And then for the liters, again, we're using 1/10 of a liter, or 0.1 liters. So I multiply 0.1 by 0.1. Well, that gives me 0.01 moles of sugar or salt, whichever one it is I'm talking about. So I want 0.01 moles of sugar and 0.01 moles of salt. That'll give me the same number of sugar molecules and salt molecules. Again, we're trying to make a 1-to-1 solution here. But not 1-to-1 by mass or volume, but by actual particles. Okay, so now to find the grams of the salt and the sugar, I need to find the molar mass. So I'm just going to Google this because I'm lazy and because I want to show you that you're allowed to do this too. So I can just say molar mass of sodium chloride, and it gives it to you, 58.44. It's beautiful. So I'm going to just slap that in there, 58.44 grams per mole. And then for sugar, I'm going to do the same thing. Now, I think if I just type the word sugar, it gives me a weird thing. Oh, no, it does it right. Yeah, so it knows that sugar is actually the molecule sucrose. So if I did the same thing of sucrose, it gives me the same answer. So 342.3 grams per mole. 342.3 grams per mole. Kapow! Beautiful. So now we have the molar masses. We know the moles that we need. We can go and use the second equation to figure out that. So finding mass of salt and sugar. So remember, the mass is equal to the moles times the molar mass. So if I need 0.01 moles of salt, and then I also need 0.01 moles of sugar, then the mass is going to equal 0.01 times the molar mass. So we look back up, the molar mass of salt is 58.44, so I'll just Control C and Control V. So those two numbers multiply together, and then here we're going to have mass equals 0.01 times, and then, but this time for sugar. Bam. Okay, so then I need to put this in my calculator, so I can, again, copy it and then slap it in the calculator app. Calculator. Bam. Thought I could. Maybe I'll just Google it instead. Aha! There we are. So 0.5844. It's a pretty small number. That's grams. So half a gram. That's not very many grams. I might have picked too small of a number here. Well, it'll be okay. Okay, however, for sugar, it's going to be a little bit bigger. So then this will be 0.1 times, whatever it is, 342.3. 3.42, of course. So you could also do that just by moving the decimal place. 3.423 grams. So beautiful. So we got our two numbers. So now to go ahead and do the mixing. So I need this many grams of salt, and I need this many grams, this is salt, and this many grams of sugar. Okay, so onto the mixing. So we're going to measure out both the masses of salt, and then we're going to add them to our beaker, which we have here still, their beaker. Then we add the water up to our desired amount. It's actually important you do this in this order, because if you imagine that I filled this beaker up to 100 milliliters, and then I started adding stuff to it, the volume would actually go up a little bit, and then you would end up with the wrong volume. So we always actually add the solids first, and then add water up to the desired volume. It's a pretty important distinction, but once you kind of get it right, then you'll get it right in the future. Then we're going to do our best to dissolve the solids. I think we'll be fine, because I did not pick very large masses for our calculations today. Okay, so I'm going to switch over to my document cam. Bam. Okay, so you can see that I got my beaker here. I have some table sugar that I pulled out of my kitchen, so it's right in there. And I have some salt that I also pulled out of my kitchen. This is kosher salt, but it's basically the same thing. So we got all our stuff. I don't really need safety glasses because I'm wearing glasses, and also this is salt and sugar, but I'll put them on just because I miss being a scientist. And then I also have some water that I just got out of a Brita filter and then poured into this flask, and I'm going to use for dissolving stuff. So, first step, let's measure out some of the salt. Oh, I killed it. Here we go. So, if I remember correctly, I need 0.5844 grams of salt. Maybe I'll add that to my text thing here. So, salt is 0.5844 grams, and then sugar was 3.423 grams. Oops. Bam. Okay. We got it. Okay, I had a little weigh boat and then I lost it. Let me figure out where I put that before I carry on. Uh-oh. I need something to put this on so I don't put it directly on the scale. Well, I mean, I actually could just use the beaker. That's not the worst thing in the world. Okay. I'm not sure you're going to be able to see it as well, though. So I can put the beaker on here and it's going to give me some mass, but I'm going to get rid of that by tearing the scale. So again, I'm not sure you can see because it's kind of, the scale is kind of light. Maybe I'll turn on the lamp. I don't know if that's any better. Oh yeah, you can see it, so 0. So now I'm going to add salt until I have 0.5 grams. It's going to be pretty tricky because I have a decent amount of salt in here. Bam, 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 bam. Bam, 0.5, I already got 0.6. So maybe you can see this is really not a lot of salt, just a tiny bit. Really, really small amount. Now, when I go to add the, so I'm going to re-tear the scale, and I'm going to do the same thing, but this time I'm going to add sugar. Now, notice that I'm adding much more mass of sugar than I am of salt. So I'm adding almost like 6 times as much sugar as I'm adding salt. So I'm going to go in here, and again I need 3, this time I need about 3.5 grams. So that's 0.3, 0.4, 1.5, a little bit more, 2.5, 3.1, 3.3, 3.4, just a tiny bit more. Actually, no, 3.4 is closer. So yeah, we're actually right on the money. So notice that I added a significant amount more sugar than I did salt. That's really important because what's tricky about the whole situation is that the masses are going to be significantly different even though I want the same amount of each molecule. So this is really where the molar mass comes in handy. And where your average kitchen chef wouldn't really be able to, not that they wouldn't be able to, but isn't really thinking about this. We tend to measure things by mass and just use that as an approximation for how many molecules there are. But if we really care about having exactly the right 1-to-1 ratio, that's what we got to do. Okay, so now I'm going to move my scale out of the way before I accidentally get it wet. Or break it. Just threw it there. It's awkward. Be fine. And now I'm going to move my salt and sugar out of the way, and I'm going to add until I have 100 milliliters. So now right here I have 0.01 moles of sugar and 0.01 moles of salt. But in order to make a 0.1 molar solution, I have to still add the 100 milliliters of solvent. So these are both solutes, but I need solvent. So I have my handy dandy water here, and I'm just going to, for now, I'm just going to add up to maybe like 50 or so. Maybe 75. 75 will do. So I've added about 75 milliliters of water. You can't really see because, of course, maybe you'd actually be able to better see in this camera here. A little bit less than 75. And I'm just going to, there's nothing exciting about this part. I'm just going to try to dissolve this. Now, this might actually be kind of difficult because there's not that much water in here. But it's, as you can kind of see in the dock cam, maybe I'll turn off the lamp now that we're not using the scale. You can see that it's actually getting pretty clear. There's a little bit of salt and sugar kind of stuck at the bottom. I'm just going to keep stirring it up. It's doing all right. It is actually just about gone. There's a few crystals left. But that's it. That's all I see anyway. Very difficult to see, but there's a few more crystals. So what I'm going to do is I'm going to very carefully add solution until I get up to the 100 milliliter mark. Very carefully. Now, this is not all that careful because this is just a beaker as opposed to some kind of volumetric flask. But, so I've got it to 100 milliliters, and maybe that extra water will help me dissolve the last bit of salt or sugar. And it looks like it's done it. So from my perspective, this thing seems pretty clear. There's not really any, wait, the lamp's still on. At this point, oh, that's what the problem, the lamp was still on. There doesn't appear to be any salt or sugar there at the bottom. I'll even put it up to this camera, see if you can see it there. Pretty much perfectly dissolved. You'll also see that I'm awfully close to the 100 milliliter mark on this, though a little bit, it's hard for me to hold it level for you to see, but just about the 100 milliliter mark. So we've done it. We basically successfully made a 100 milliliter solution. Let me go back. We basically made a 100 milliliter solution of 0.1 molar salt and 0.1 molar sucrose or sugar. So we have a 1-to-1 ratio. So in this jar, there's exactly, or close to exactly as we could measure, the same number of salt molecules as there are sugar molecules. And we had to use the molar mass, we had to use our understanding of moles and molarity to make that happen. So this is really the goal of this fundamental, lesson about molarity and everything else. In order to really understand what's happening at the solution level, we really need to start thinking more about individual molecules lumped together in solution as opposed to just relying on our understanding of mass or volume. And so that's really the goal here. So I'm tempted to drink this as sort of a sign-off, but just because this is going on the internet, I don't want to be incriminated in the future, so I'll leave that to your imagination. But yeah, so that's that. Thanks for watching. Hopefully you learned something, and hopefully that helped to justify a little bit why we were going through the process of talking about molarity, solution, solubility, and all that jazz. So yeah, have a good weekend.